Welcome to today's Software AG webcast titled Database for zIIP, Save on Mainframe Costs. Today's webcast will be presented by Becky Albin, Senior Director, Systems Engineering, and Dave Tipler, Senior Director, Database Mainframe Product Development, both of Software AG. As we move through today's presentation, I invite you to submit any questions that you may have via the Q&A box, which is located in the top right corner of your webcast dashboard. We will address your questions at the end of today's program. In the event that we're not able to answer your question, your submission will be recorded, and today's presenters will be back in touch with you as soon as possible. Additionally, today's presentation is being recorded. This program recording will be made available to you in an email that will be sent to you later this evening. Before I turn today's presentation over to Becky, I would like to briefly introduce you to Software AG. Software AG helps companies with their digital transformation. With Software AG's digital business platform, companies can better interact with their customers and bring them on new digital journeys, promote unique value propositions, and create new business opportunities. In the Internet of Things market, Software AG enables enterprises to integrate, connect, and manage IoT components, as well as analyze data and predict future events based on artificial intelligence. The digital business platform is built on decades of uncompromising software development, IT experience, and technological leadership. Software AG has more than 4,500 employees, is active in 70 countries, and had revenues of €872 million in 2016. It is now my pleasure to welcome Becky Albin.
Thanks, Will. Welcome, everybody. My name's Becky Albin, as Will said, and I've been around for a long time, and I was looking at the attendee list of people who've signed on, and I know practically all of you, so welcome, and I hope you find this webinar very informative. Sitting next to me is Dave Tipler, who's been around even longer than I have at Software AG. And Dave is the manager, the director of Mainframe Adabas R&D. So I invited him to come and be part of this webinar so that you guys could get the inside scoop on Adabas zIIP and how it works and all of that. So with no further ado, I'm going to go ahead and get started on the webinar. And for some reason, my slides aren't paging forward. There we go. Okay, so what we're going to do is just do a quick overview of what is zIIP, a little bit about Adabas zIIP and some of the other Software AG zIIP products. We'll talk about the easy installation and configuration of Adabas zIIP. Dave will talk about the changes that were made to Adabas for zIIP support. Dave will review I always stutter on that word, the statistics for Adabas zIIP and how to determine how much CPU you're offloading from a main processor to a zIIP processor. And we'll go through some live customer examples from our beta test process. So most of you have heard about the ANN 2050 campaign that's been going on for a couple of years now. Just to know that Adabas and Natural is not going away. We're still constantly developing new features and enhancing the products. I don't have a lot of time today, so the one piece of the ANN 2050 initiative that I'm going to talk about and that zIIP falls under is the optimized component, where we are going to lower your cost, your total cost, and improve operations. In addition to that, there is the fact that Adabas and Natural can live in a completely modern digital world. You can integrate it, you can modernize it, you can teach younger people how to program in Natural easily with Natural One, and you're using DevOps and containers and all this stuff. So today's focus is going to be on the Adabas zIIP component, which is optimizing and lowering your cost. Just at a high level, what is zIIP? zIIP is a specialty processor that comes on the IBM mainframes for the ZOS operating systems. It's not available for VSE or any of those others. So, and you know, on this slide we have what zIIP actually stands for. It stands for Z Integrated Information Processor. The key thing to know about a zIIP is that when you have one or more zIIPs, and how many you have is depending upon your contract with IBM, but you can have one or more of these zIIPs. You can only have as many zIIPs as you have general purpose processors. But what we do is, or what IBM allows you to do, is offload a lot of your zip-eligible work. And zip-eligible work is basically anything that doesn't require an I/O. And Dave will get into all the technical details of that as part of his session. But the cool thing is, by offloading a lot of the Adabase and natural workload to zip engines, you're going to bring down your overall CPU usage on your regular mainframe engines. So by reducing the workloads there, things may run faster. They may run the same time, but they would definitely use less CPU. And by using less CPU, you can potentially postpone hardware upgrades. And also a key factor for a lot of our customers who are already running natural zip, and many of you on the webinar are running natural zip, is it allows you to lower your 4-hour rolling average, which we'll talk about in just another slide or so, which means you're paying IBM less because you're offloading from your general purpose processors over to the zip engines. And I'm trying to keep an eye out on my time here, and for some reason I'm having trouble moving slides. So as I mentioned earlier, natural for zip has already been around for a long time, since 2012. It's hard to believe that's been 6 years ago already. But it started off with batch natural that was offloaded to zip engines, and some of our customers have seen up to 95% of the CPU offloaded to zip engines. Then in 2017, last year, we introduced natural online zip, which meant for CICS complete or TSO type of operation. So those are under your natural online, and those offloads, our customers are seeing up to 85% offload for that. New to 2018, and actually just this week it was officially released, is Adabase for zip. And some of our early beta test customers who were performing various tests for us, and Dave will go over some of those examples as part of his session here, is they've seen up to 90% offload of Adabase to the zip engines. And as a lot of you know, Adabase, in a lot of cases, uses more CPU than natural does, whether it's natural online or natural batch. So having Adabase be able to offload CPU to the zip engines can be very, very, very beneficial for you. So if you take a look at compiling or combining Adabase zip with batch natural zip and possibly one of the natural online zip components, you can offload a significant amount of your mainframe workload, depending upon how, what percentage Adabase and natural is of your total mainframe CPU. And then coming later in October, there's going to be another release of Adabase zip, which will support Adabase 8.4 and some additional add-on products. And there's always, as with all Adabase and natural products, ongoing enhancements. So what this slide is showing you is that if you're paying IBM based upon a 4-hour rolling average of your CPU, and let's say that your CPU is, and this is representative of your CPU, when you look at that top dotted line there, where the dotted line kind of goes up and down like a wave, so that's your rolling 4-hour average without zip. And if you look at the rolling 4-hour average peak, you'll see that natural online and Adabase and maybe some batch falls into that environment where that's your peak 4-hour rolling average. If you were to put Adabase zip and natural zip in place, then you can bring your 4-hour rolling average down fairly significantly, as shown in this diagram. How much? It will vary from customer to customer, but it will be significant cost savings. And the really nice thing about Adabase zip and natural zip is it really does not require any changes to the Adabase database on your part, like no new data sets, no new functionality that you have to worry about in putting in, no code changes to your applications, none of that. You just put it in, it works. And we'll get into exactly how that works as part of this session. So, the goal is to reduce your cost as much as possible by using zip components. And so, again, there's Adabase zip, natural online, and natural batch. Okay, so how can we help you figure out whether or not Adabase or natural zip will help you? So what you can do, a couple things. One is you could provide us some SMF data, and practically everybody on this webinar has sent us SMF data for analysis, and a lot of you are already running natural zip. So if you want, you could send us some SMF data. We could analyze the Adabase piece, the natural piece, both pieces, and we can give you a very good estimate of how much CPU we think we could offload. Another easy way to test how much Adabase or natural zip can save you is do a free trial. Put it in, test it, see how much your CPU comes down, because there's never ever anything quite like really using the product to find out how good it actually is. So the whole idea behind the zip products are to bring your CPU usage down, which will be saving you significant amount of money. This session is primarily for the Adabase zip component, so I'm actually not going to spend a whole lot of time on this, but just wanted to make sure that everybody was aware that if you do have natural applications, there is a natural for zip. It works with natural online, natural batch, the various online components, kicks, complete, whatever. It works with RPC servers, natural role servers, all the stuff that's listed here. And again, to highlight, there are no changes needed to your natural applications. The only prerequisite is you have to be at natural 823 or higher. Now, the Adabase zip, and I'm still having trouble, here we go. Okay, so the Adabase zip, now this is kind of interesting. So Adabase zip is going to allow you to take a lot of your Adabase workload and move it from the main processor over to the zip engines, depending on how many you have. It is the nucleus, it's caching, it's delta save, it's parts of online AOS, and cluster and parallel services. And Dave will go into more detail on this. But the really cool thing is, notice over here in the little diagram to the right, it really doesn't matter what your applications are written in. Remember, this is Adabase, the nucleus getting zip enabled. So it doesn't, and you know, to Adabase, everything's a direct call. I don't care if you're writing natural, COBOL, PO1, Fortran, whatever. To us, it's just another call. So we can zip any application that's calling Adabase. So all that will be offloaded. So as I said, this week, the Adabase zip for 834 is available. In October, it will be 8.4 Adabase that will be supported, in addition to some additional add-on products, which Dave will talk about in a second. And my next slide should just be a very quick slide that would show you what's involved when you want to do a trial of Adabase zip to get it up and running. So for today, you need to be at 834. When you get the software from us for Adabase zip, you will get a fully zapped up 834 Adabase library. It will come as a AZP 835.load. That is 834 plus the new modules AdaZip and AdaNCZ. Those are the ones that are zip specific. So that load library will have your Adabase 834 plus those two modules. There are a lot of assemblies or reassembles of the Adabase nucleus for zip, because as you can imagine, Adabase IOR, which is your IO stuff, and all the other internal things all had to be, changed, and Dave will talk about some of that coming up. But it is 834, just a fully zapped up version. You will have to install a new SVC because the SVC had to be zip enabled as well. And in addition to the regular Adabase license key, there will be a license key for Adabase zip. So there's a total of two keys. Once you've got the load library in, installed the SVC, got your license keys in, all you do is you start your database with a new AdaRun parameter zip, and it's zIIP equals yes, and you're off to the races. You have to be ZOS 113 or higher. And again, the first release that supports 834, it does support caching, delta save, and a couple of the other add-ons. More and more add-ons will be coming. Just to kind of to show you some of the savings that you can get by using zip, I put up a couple of sample use cases. So, and this may or may not be representative of your environment, but it'll give you an idea of some of the costs that you can save. So, let's say the Adabase is only 20% of your total mainframe workload. but you offload about 70% with database zip. And let's say you also have natural zip. And natural accounts for about 30% of your workload, and you're offloading 60%. So then you can see, based upon the number of MSUs and your software cost per year, you can see that some of the savings are pretty significant, you know, like maybe $500,000 or over $1 million a year. And if you go back to some of the webinars we did last year with actual customers, you know, they're reporting savings of over $100,000, $200,000 per month. So there's some significant savings to be had by offloading your database and natural processes and workload over to zip engines. And now I'm going to turn it over to Dave. Again, Dave heads up database mainframe development, and he's going to give you the inside scoop on how all this really works. Over to you, Dave.
Okay, welcome to the meeting. So picking up from where Becky left off, I just wanted to step back a little bit and just talk about the zip again. So this first one is basically from an IBM perspective, so I guess a little bit technical, and then I'll talk a little bit about the database and then move on. So again, as Becky indicated, then it's a special purpose processor. We had the zips and zaps. The zaps actually more, so we just have the zips now. And the idea then is that we want to offload off of the GP or GPP engines and put them onto the zip engines. When we are running under zip, then the workloads have to run under the control of an enclave, and which is a group. I come to that in a second, but basically you're running under an SRB. So you are in a problem state if you're looking at the code, and anything that needs to run as a TCP would have to run on the GP engines. The enclaves that you set up are also able to be managed by Workload Manager. So when you're looking at your total machine then that you have the engines which are running in the GP, your engines running under the zip, and all of this, according to your service class priorities, is managed or overlooked by Workload Manager in terms of the dispatching priorities. Your zip engines may be depending on how many you may have some zip engines dedicated to a particular LPAR, or you may have them dedicated to the machine, which means multiple LPARs. It's up to the customer how they want to do that then. So anything that runs on the zip engine must run as an SRB, and anything using system services, which is I/O, printing, operator commands, then may not be run as an SRB, have to be run on the GP. So at the bottom here, I've mentioned here, in case that you don't have zip engines, that there is a way to do a projection of the amount of offload or what would happen if you ran a zip engine. I have actually personally never run this, but this is from the natural, the team in the natural development, that this is the settings for the customers that they had, that you just have to change this. So if you need any help on that, then you can always get help from us for that then. All right. From the database side, just to let you know then, so we're licensed with IBM that Software G products can run on these zip processors, but these licenses explicitly disallow Software G from executing code that's written by the customer or third-party vendors. So if you have user exits that you've written, I was at IBM last week and I tried to negotiate that we get this changed, but it's very much hard set though that we cannot execute any of the customer code or anything from third-party vendors. Okay, so when database comes up, it establishes the enclave, and the enclave is representative of all the work that we will be doing running for that database session. So when we initially start up then, we start up as a TCB, we do some initialization work, establish the enclave, and thereafter everything runs under the enclave. One thing that's a little bit different that we will do here is when we did the initial prototyping, we discovered that it was pretty expensive to do mode switches. Mode switches is I'm running in TCB. Now I want to switch to an SIB. That's a mode switch. Then I want to switch from the SIB to TCB to do some I/O. That's a mode switch. We discovered that that was really expensive, so we decided not to go in that direction because the objective here was just to optimize the performance overall. So what we did is that we now have multiple tasks. We can call them dispatchable units. That's the technical term for it, and then we can run an SIB and a TCB running in parallel, and I'll talk more about that later on. So for the conversation here, the TCB, I'll talk about task mode, and for SIBs, that's zip mode, and sometimes they interchange depending on the topic of them. So as long as you understand what that is then. This part over here then I normally put in, but Becky did a great job of explaining all of this, so I won't explain about what the purpose of what our objective was. You can see that once you get the slides in. When we turned around and decided to do this zip enablement of Adabas, the decision there was, or the idea was, is that we wanted to prevent as much efforts going between TCB and SIB from the zip mode over to the GP. So what we had to do is we had to zip enable all of the code that runs in the Adabas address space. So over here, then you'll recognize that there's a number of add-on products like the caching, Delta Save, the parallel services, replication, review, Vista FastPath. All of these products then, anything that ran in address space, any code that was in there, we had to make sure that it was zip enabled. In the end, then it ended up not being so much code that we had to specifically change in our code, which was an important factor I'll come to in a moment, but that was an important aspect. When we go to 843, and this is probably the last time I'll talk about 843, then what will happen is that what we're currently working on at the moment is zip enabling review, replication, and network. The caching, Delta Save code is all zip enabled now. AOS is basically zip enabled through natural for zip, but any of the assembler part that runs in the Adabas address space, then that will also be zip enabled. Oops, sorry, slow on the. All right, big picture overview. I've got a more detailed one later on. But when we come up, as I indicated, we come up in zip mode, and then we immediately introduce parallelism. I've been able to run some work on the SIB and some work on the TCB. So over here, I show two different machines, but in actual fact, they usually are one machine, and you'll just have some of the engines assigned to be zip, and the other ones are just GPs. So what happened is if we have any work that needs to be done on the TCB, then in essence, one of two things will happen is that we do a mode switch, or which normally happens is that we'll do parallel execution. And the mode switch, there is a couple of areas where we had to make changes that we discovered that when you're running SMF records on the Adabas address space, that when we ran in dual mode, in parallel, that the statistics was not logically consistent, because once we queued the work up for the GP, by the time that we were reporting on the SMF statistics, some of them may have changed in global memory, which means is that the statistics were not logically consistent. And so we had to do a mode switch whenever we do that. Another one for now then would be the user exit 12, which is when you're doing octo plogs, octo command logs. And the reason why is because at the moment then it uses global memory, but when we get to 843, that one will also be able to have a parallel execution, i.e. no mode switch. But it was a lower ranking priority in terms of what we zip enabled. And the reason is that if you're doing plogs and clogs, it's not as often that you would do a log switch like you would do with the commands. And so that was the most important thing, is to get the work for the commands zip enabled as much as possible. Okay, there we go. So one thing I wanted to highlight from what Becky said with the 834 is that when we did this, so we had discussed this with sales then, and actually specifically Joe Gentry, and the idea was that we wanted to make sure that the customers running on 8.3, which was most of the customers at that point in time, we wanted them to be able to easily move over from the Adabas 8.3.4 basis, or could have been 8.3.3, 8.3.2, doesn't really matter, but we wanted to be able to enable them to move over to being able to run with zIIP. So in terms of when we did the code, we didn't change the functionality of Adabas itself. Everything is conditional. There's a couple of things that we had to change, like Becky mentioned, on the dependent code. But what happened over there then is that we do a detection that we're running in zIIP, and then it goes off and it says, okay, certain things need to run as a TCB, and other parts it can just run on the SOB as normal. And that would be like memory functions. If we're trying to get some information out of ZOS, for instance, that's just memory, and that would run under an SOB then. But what we did then is, like we do with other products, is that we isolated all of the zIIP dependent code into a specific module, AdaZIIP. There was another module on the that we had that we consolidated the independent code, i.e. that's not specifically SBCs. It's just logic that we have for being able to be zIIP enabled, and we put that code into a separate routine. And what this does is it enables you to switch over from your 8.3 over to the AZP with minimal impact. We've had a number of customers running with this, and from the onset, we've had very few problems reported. If anything, I think the only one that came up then, which was difficult, was the recovery. If an outage actually happened, how do we actually recover? So during testing, we discovered things over there. But now this is all fixed for the release, which we currently have. All right. So other changes that we had were zIIP specific. So there were session statistics that I will tell you about so that you could see what's going on. And actually, we needed information as well. So there's some extra ones for us specifically, but you can see them. With the AOS, we also zIIP enabled that. But when we did this, for those people who actually don't have a license for AOS, you can still install AOS, but there's a subset called ABS that would still allow you to see the zIIP statistics, the zIIP information, and to do the operator commands in. So that was that you weren't limited by other prereqs or products for you to be able to run with the zIIP for Adabas for zIIP. DZStat is a new operator command, which enables you on the fly to be able to issue the command and to see the statistics. And for instance, you want to do a DZStat, run a batch job, run the DZStat, and at the end then you can look at the stats and you can see the delta between them. The session stats will gives you the overall stats at the session termination, but the actual DZStat then shows you, would enable you to see the deltas. We also put in the zIIP command. That means is that when you bring up your database with zIIP, that you can actually disable the zIIP for some various reasons. It could be that you decide one particular database you don't want to run it zIIP enabled. It could be that you want to just run it zIIP enabled only for the batch windows. It's up to the customers, but we wanted to give you the flexibility to do that. Because of the DZStat, we changed refresh stats so that you could see the statistics base reset from 0, then you can see them without having to do the calculation of the deltas. The other thing is on AdaRep then, from our point of view, one of the things was is that when the users were running Adabas for a long time, the sessions gives you the overview from the big picture. By adding the statistics into the Synapse 60, what we were able to do is to see the statistics across different intervals, and that gave us specific information for us to be able to understand what's been going on while zIIP has been going. And when you look at the stats, I can talk a little bit more about that then. Here's just a snapshot of the statistics. So it's quite different. These ones on the left are for you. These ones on the right are for us. But you can look at them as well. So these ones over here, then there's some general information that we like to know is how many engines that you're running, because it does matter in terms of how the workload manager dispatcher works in. There's a normalization factor, which is telling us how much faster your zIIP engines are running than your GP engines, because we get different results based off of this in terms of the throughput. This over here, the enclave. So the enclave is what actually happens in terms of how much time that we actually spend. Actually, this is on the GP. So when we talk about the GCP was the one that was used, but I think that we'll probably go back because Netflix used it. But I spoke with the lead on the Netflix side to see whether or not we could go back to GP. But I'll just use GCP here for now. So this one is what actually runs on the GP. And there's various reasons why we'd run on the GP, for instance, initialization, if we're doing IOs, if you user exit. This is the total amount of time that was utilized for this enclave. This is the actual time that we spent. And so at the end, then you do the simple calculation. It shows in this particular case, it was 88%. So this is lower than most of the customers that we use this in. Most of them were running in the 90s, but it depends on what you're doing and your environment. If you're using user exits, these variations of why they would drop them. Over here was telling us what's eligible, and the reason why eligible is relevant is like we've got the one customer who's running 40 databases. They have one zIIP engine. Well, depending on how much load that they put on it, it could happen that the dispatcher says, oh, there's no more resources on the zIIP engine. I'm going to offload this from the zIIP engine back over to the general processor. So this shows us, in this particular case here, how much time was spent on the general processor because we couldn't put it on. So, in fact, what the customer can do is get another zIIP engine to offload. So that's something in your configuration or your planning, that's something that you would want to probably look at closer depending on your results. This one over here, then, it's just telling us the number of mode switches that you do. It could tell us why the numbers were lower up here. This is what we're looking at. If this number goes below 70, then typically they would send me the stats and I would go through them and I would be able to go through and identify, oh, it was due to this, it was due to that, whatever the case was. One that I had after the beta test and I added in was this one down here, parallel requests per TCB. When I look at this number over here, it tells me that the database was actually not loaded up. And when I looked at the actual jobs that the customer actually ran, they were running a set of batch jobs. So it would be a burst of activity, then nothing, then a burst of activity. And overall then, that caused this number to go down. But then what that does is it caused these numbers to go up. And I'll talk about that in, oh, you can't see my mouse? Oh, okay. Sorry about that. I've been pointing and thinking that you could use the mouse. I don't use WebEx that often. Okay, so the pause for wait. Sorry, so when I've been talking about the total enclave, that was the top set on the left-hand side, total enclave CPU time. The eligible one is the eligible zIIP CPU time. The switches ones over here, those are the ones that refer to some of the statistics about what's going on, why we're doing modes, the number of mode switches that we do. Free elements and parallel request, and that's the one. The parallel request per TCB pause 1.15 is low, which means to me that the nucleus was not that active. So the extended statistics are the ones that we've put in for development. We talk about EXCPs. That actually is I/O. Operating commands, that's obvious. Sequential writes would be if we're writing to print, for instance. Timers, as you all know, that we have a lot of timers that are out there. We wanted to specifically track user exit 12 that was out there to discover whether or not the user was doing a lot of switches, because that's one of the things that would actually cause mode switches, and so we would track that specifically. All right, sorry. This one over here was just a summary of the user exits. So the user exits may not run in zIIP mode, IBM stipulation. not us, must be executed in the TCB. So any CPU, if you're doing a lot of work in that exit, then it'll use up CPU on the TCB, which means it'll decrease the overall percentage that we had, this number over here, zip enclaves percentage. That will drop if you do heavy work in your user exit. So, but I'm sure that most people don't do that anyway. Invocation of the user exits, they're done in parallel, and there's a couple that require a serialization, which is the user exit 1 from Delta Save. Don't know that a lot of people actually even use that one. Exit 12, which is octo plogs. You can see these over here. Exit 8 is just, if you're doing a lot of operator commands, and then the exit 5 for review, but I'm not thinking that people should be using that one too often. All right, so hopefully you see the animation over here, and so this is the one that's giving you the overall view about what actually is going in. So I'm not going to read this. I'm going to just look at the picture and talk. Sorry. All right, so we get a command coming in from the client, and it goes into the command queue. So there's no changes there. When we did the zip enablement for natural, we zip enabled the ADA link for them. So there's no changes that we had to do on that side. Once the command gets selected to run in the in a thread, what happened is we'll run through the code, and at some point in time, then if we discover that there's something that cannot run on the SOB, we'll have a look. We've got two choices. One is, do you have to do a mode switch, which we will do. So that basically is that short serialization that we do. But otherwise, what happens is that we will then take that unit of work that we've got. Let's say it's an I/O. We will do that I/O, and then what happens is that we will queue it up to go to the TCB. So where we're doing this execution of SRB, that's where most of the work is actually going on. Stop moving over here for me. You have to just click on it again. We should go, maybe not. Okay. All right, the animation disappeared. All right, never mind. Words. So goes from the thread. We're running any code that can run on an SOB, gets put on the zip engine. Any code that can't, it gets queued up to go down onto the GP. And then you can see over here, then this is showing you a number of requests: an open and close to a data set, I/O, of reading, writing. If we're going for user exit, if we're doing printing, any of these which ends up in an SVC call, all of these get queued up for over here. What happens then is that we keep working over here, doing the work of pulling anything from the queue while we're processing. But meantime, when we have queued work to run on the GP, sorry, single right wording over here on the GP, what actually happens is that thread gets suspended like it does today. If we're doing I/O, we do the I/O asynchronously, that thread gets suspended, and then we go to the next thread, higher up, that's available, ready to run. And we keep going in. When the work is finished down on the GP, it turns around and updates a flag on the thread, which says that it's now able to run. When we then select that thread to run, it will continue running from where we left off. So this way, we were able to get parallelism of executing work on the SOB and executing work on the TCB. I hope that covered all the things I had. So a lot of parallelism. All right, over here then, I'm not going to go through this here because you're probably short on time once I get to the stats part of it. So this is just an explanation of what I actually told you earlier on. And you can read that later on. It's in the documentation for the AZP anyway, so you can read up about that then. But this is the ones, in my viewpoint, that you can get, that you're most interested in. Of all the work that we had, what was the percentage of the workload that we got off of the GP and onto the zip engines? And that percentage of work that we've taken off is freeing up work for other things or reduce costs on your GP. This one over here at the bottom where I talk about the enclave, GCP, CPU time. So this is actually when just to let you know that you understand it, so to set expectations. As I mentioned earlier on though, there's work that gets done on the TCB. And what I decided to do here is to explain specifically what it is. Execution in TCB mode, when we're doing startup and shutdown. Then when we get parallel requests, i.e. the IOs, the printing, open data set, then the user exit, that is also attributed to the TCB. And then when we have a circumstance that for some reason the dispatcher discovers that there's no resources available on the zIIP from the zIIP engines, it turns around and it offloads it onto the GP, because according to the workload manager, in terms of the service class priorities, it's a high performance. So we want to, regardless of whether it's running on the GP or on the zIIP, then is that your lower performing higher performing address spaces do get service. If your high performance address spaces are all running on the zIIP, that means is that your lower performing address spaces, batch jobs for instance, or other address spaces that you may have out there, network review, whatever the case is, they would then get more priority in terms of dispatching time. So at the end then, you should see more throughput from the results. Okay, so these are the additional statistics that I talked about. So since we're going to show this to the customers, there's an explanation of what these all are over here. I talked about them earlier on. Well, the one thing just that I'm mentioning here, and I know we don't like to do it though, but I hope it is in the documentation, these are subject to change. The point here was if somebody says, well, I'm not getting as much throughput as I expected, or why is the percentage so low? What will happen is support will send this over to one of the developers, and we'll look at these statistics. We'll get other information from you, and it will give us a good feeling about why that is like that. And what we don't want is that the customer is saying, there was one site that I was in Germany when I was visiting, and they said, oh no, our database has been up for 9 months. Okay, we know that you can't bring down the database, so the idea was is that we want to be able to do this on the fly. That's why this is in the DZ option, that you're saying, oh, we were running this, the database is still in production, it's up and running, we don't want to bring it down, we will get these statistics from you. So that's the use case for that. The other thing that we look at is it's very important, well, for me it is, it's very important to see the JES log. Because when we're looking at the stats, these ones you're familiar with, the session statistics, which is lower left, showing duration, wait time, and CPU time. It's pretty amazing that of all the people that have been running Adabas on the zIIP, a lot of them haven't fully loaded the system, and I see a lot of extended wait time over there. So it means is that Adabas has more capacity to be able to run. So the CPU time IEF032I message is the one that looks at specifically at the Adabas step. I know a lot of people may run an ADA rep, they may do a reset dip, so it means they're running an 80 dBs. Those run in different steps. If you look at the IEF033I message, that will show you the stats for all the jobs. The ones that we are interested in is the ones for our particular step. So you see up in the upper left, the IEF032I, this is what the message actually looks at. And what's in green is what is showing us going on with the CPU, and then in the ones in the, I guess it's a yellow and orange, well, it didn't come out so well, that's the SRB times. And we've discovered now that there can be, like when you do the cross-memory post, when you're going from the ADA link over into the Adabas address space, this drives up the SRBs. We'll probably change the statistics later on to reflect that as well. But this is why, for instance, we want to be able to look at those, that information in there. But it helps you to see the overall charge back or the cost then of the CPU. And it should be a lot less. So in this job here, what we did is we ran a job. This is right up in the early days, but I wanted to show you on the stats over here. On our zIIP engine is almost 11 times faster than the GP, that particular GP that it was running on. We did a lot of mode switches, so we've reduced those subsequently. We're looking at the total timers. So this one over here, you'll see 4 minutes sorry, that's minutes. So the first one is hours, and then minutes, then seconds, and then milliseconds. The 0.984 that you see under total enclave is milliseconds. When I spoke to the natural people, they told me that some of this stuff was so fast that the total showed 0. So we did the best of both worlds. We showed the hours, minutes, and seconds, and then also to see the milliseconds, and we included those as well, then, so that we're compatible with the natural people, then. And on the left-hand side, you can see the zip run of this job and the non-zip. So interesting then when they ran the job, this one that we're looking at over here, is obviously there was a lot of wait time, different from when we were running on the non-zip. So the non-zip was only like 35 seconds, and over on the zip one was 2 minutes 12 seconds, because we got the work executed so fast that we spent more time waiting, and that part it runs on the TCP, GPP. But look at the CPU time, 6 seconds, and then, sorry, 0.6, was it this one? I think it's 6 seconds, right. And this, sorry, been seeing too many statistics recently. And then the other one, this job ended up using up 16 minutes, 29 seconds. That was a huge difference that we got in this particular job. One thing let me just mention, and Becky talked about it earlier on, when you're running your jobs, everybody's different. The workload that you run with those particular commands in that particular sequence, you know, and you've got things like the cache, if you're running with AWS cache, the size of your buffer pool, that we know to do IOs, then that will have an impact if you're doing a lot of randomization. You know, that also will result in differences in how the workload gets offloaded onto zIIP. But we had one customer that the first thing they did is they ran a regenerate of the database onto a new database and monitored onto zIIP. And we hit 90-something% on that, or it was upper 80s, I can't remember, but it was up there, really high, heavy I/O. We got really great performance on that when we did that, and that was very heavy I/O, obviously. So let me take you to the next one over here then. So this one was an actual customer that was done recently, and I think this up here is wrong, the comparison of 4 jobs. That looks like I forgot to take that off. I only just saw that now. So on this one over here then, straight away what I looked at was, if you look up at the top left-hand corner, is I see that we are, duration is a long time, wait time really very close. So in actual fact, for all the workload that this customer actually did, which actually was a lot of workload, it was only 10-second CPU that we actually used up. I don't think that I didn't see a comparison when they ran it off of zIIP. So if you're doing comparisons and you want to say, well, how good is this? Well, you would run the first one in terms of a benchmark. It does matter if you're running other things on the machine, because if there's other workloads that are being put on the zIIP, or with the different dispatching priorities, which is higher, then from some of the statistics I got from customers, I could see that it did change the statistics. Because if we're waiting to get dispatched, what happens is that there is a number which I talked about. It's not on here. Oh, yes, here it is. The pause for wait and release for wait. As you know, then when Adabas has got nothing to do, it goes into wait. It doesn't do a spin and is using up CPU. It just waits. And then either there is a command coming in, or after 5 seconds, it goes in and checks to see if there's anything else ready to run. Then it picks it up and executes it. And so the pause release waits, when these are high, which in this case it was really high, it told me that this database was not waiting. And that is emphasized by the duration time then. There was something else I was going to say about that then. Oh, yes. The other thing that I looked at, and I don't have them on here, but when I looked at the database session statistics, I looked at the number of threads that were actually active, and it showed me that there was only 2 threads. And in terms of the jobs that they were running with the regenerate, which gets some parallelism. So that would explain why that actually happened though. So this was an example that when I see this and being very open with you, come on, let's put some more workload on Adabas. Let's get it going. Let's show you how much we can offload. We spend a lot of effort on this. We want to offload all your work. So I can tell you information about this, your database, just looking at your runs by just looking at these stats. And that's why I ask you that we get this information. On this one, it's a DZ stat, all. If you just do DZ stat, it just gives you the blue. If you do the DZ stat all, then anything under extended statistics, that's what you get. So those ones, if you're wanting us to look at the information, we would want to see that information that would give us more insight as to what's going on with your job then. As I said then, it varies from user to user. I did have situations where users ran workloads in the test environment that they never do in the production. It's good to do like this regenerate all. I mean, how often do you do a regenerate all of your whole database? Not very often, but it was a good case of, okay, let's put on heavy I/O. Let's see what this new database for zIIP can actually do. And it performed very well. So the customer, this particular customer was very happy with the results for the beta that they did. Nowadays, you would just do a proof of concept, and basically what would happen is that if whoever is working, like it would be Becky in your case, she would get this information, she could give you feedback, but if she needs feedback, then it would eventually come over to us. So my last quick slide that I had over here then is in terms of, from our perspective, is that we want this, and we believe that solidly, that if you run Adabase for zIIP, we can show an improvement in the reduction of your CPU utilization. I haven't seen any bad ones at all. Everything, even if you offloaded 60%, and depending on how many nuclei that you've got in terms of your total workload that you actually offload, that is more capacity that you are making available on the GP for other things to be able to run. So we're saving on the MSUs. The key savings that we put onto the zIIP is definitely impacting on the customers that's shown the benefit. What we've actually been looking at, it looks like that we have improved throughput, both internal and external. The input, the internal, which is number of CPU instructions to CPU second, versus external, the number of Adabase commands per command second. We have shown some good results on that, but we need to do one from a customer to look at that. But definitely elapsed time, big difference. Okay, and I think that's about it from me. Over to Becky.
Thanks, Dave. I told you guys we'd get all down in the weeds. Okay, so just to close up and wrap up, I really do appreciate your time today. Hope you found this useful. If you would like a trial of Adabase zIIP or any of the natural zIIP products, just reach out to me. My email address is at the bottom of the slide, or to your Software AG account executive or your local SE, whatever. You can do a trial. You can provide us SMF data for analysis. If you want to read a white paper, there's one out there on our website. There's the link. There's also success stories from customers who are actually using this stuff in production. And there is a fact sheet for Adabase for zIIP. And if you would like a copy of this PowerPoint, just pop me an email. I'll zip it up and I'll send it off to you. So my email address is Rebecca, R-E-B-E-C-C-A, and I know none of you know me as Rebecca, but they changed our official email addresses, but Becky.Albin will also still work. So Becky.Albin or Rebecca.Albin@softwareag.com, pop me an email, I'll send you the PowerPoint, because it's got a lot of good useful information in there from Dave. So at that point, Will, I'm going to turn it back over to you. Thanks.
Thanks, Becky. First question, please. Is there a timeline for zIIP enabling the mainframe component listener of SQL Gateway?
So I don't have that information at the moment, though, but actually I'm at Connect next week, so I will bring that in our discussion and find out about that. A lot of their code is not written in assembler, and even if you're using LE, the language extensions, I believe that code is not zIIP enabled. In cases there where we have products that have C, what happens is if you do too many mode switches, it ends up being expensive. So at the end, more expensive than what you had. So at the end, then we do these benchmarks, and anything where we can show improvements, we will zip enable. But with the SQL Gateway, I have reservations as to whether or not they would be able to do it. I actually think not.
Can you repeat what database add-ons are also zip enabled?
For now, then, when you're going out with the AZP 835, so anything that runs in the database address space, so that would mean the database cache, your cluster services, your Delta Save, the AOS in terms of the assembler code then that you've got. But if you're using natural for zip, then your AOS would also be zip enabled. I think that's it. But for now, at the moment, those are the ones that are zip enabled when you get the Adabas for zip license. When it comes to October, then the other ones, and the ones that we're working on at the moment, then is replication, review, and network, and the core base products, which is the Vista FastPath, Safe Gateway, and Transaction Manager. I think that the Safe Gateway, that may be zip enabled already. I'd have to double check on that.
Other vendors have provided zip enablement as part of normal maintenance. Is this a separately priced feature? If so, what's the basis for calculating that?
This is Becky. Yes, this is a separately licensed product. You'll need to talk to your account executive because I don't know pricing or anything. So talk to your account executive. But yes, there is a license charge for this. Because as you can see from Dave's responses that it took a lot of effort and work for us to develop, and it'll save you a ton of money in the long run by offloading to the zip processors.
Are there any changes needed for Adabase to run on zip?
Just if you're running Adabase 834 today, you just need this new fully zapped up library that has all the zap supply plus the 2 new modules. But you must use this new library because there are a lot of zaps that had to be put into place, and it's not possible to pick and choose which zap. So you have to use the 834 library that we send with the AZP.
Okay, last question. I'm not sure if you've addressed it, but what are the Adabase version prerequisites for running Adabase for zip?
Okay. Okay, I wouldn't say there was tons of zips on it because we'd consolidate the code into those separate modules, but sure, like when we go to exits, there's zaps over there, just to finish off that last conversation. So when you're going in, as we alluded to, we had to pick up a base version. So we didn't want there to be any confusion between ADA and AZP. Because if somebody decides that they don't want to use the zip enablement, then they can just run with the base ADA, and the highest release of that is 834. Because that's the highest release of the 834 because of the EOM, and I think I put an extension for the EOM on the 834. The AZP 835 is based off of 834. So you take whatever we dropped over to you, we added any maintenance that was out there, and then any of the changes that we had to add, like the user exit and stuff like that, and then added onto that library is a couple of extra modules, the ADA NCZ and then ADA ZIP, and that's it. So we try to minimize it so that it doesn't look, and it isn't, a major release. All that it is just making, which most of our code was actually able to do it. We had a few tweaks and stuff that we had to be able to handle, but most of the code is based off of 834. So there's minimal changes, and that was what the goal was that we wanted to do. Hopefully that answered the question.
Okay, thanks, Dave. I'd like to draw your attention to our upcoming user groups in San Francisco and Austin on May 8th and May 10th, respectively. Specifically, the May 10th program in Austin will include a full-day session covering a variety of database and natural topics. If you would like additional program information related to registering for this program, please send a quick note through the chat or Q&A boxes right now, and we'll get that information off to you later today. Additionally, please mark your calendars for May 24th at 2 p.m. Eastern for an upcoming webcast on Mainframe to LUW rehosting. This rehosted platform can be Linux, Unix, Windows, on-premises, or in the cloud. Please visit the events section under the company tab at softwareag.com for future webcast program information. Becky and Dave, thank you very much for your time and the presentation today. With that, our program has ended. Enjoy the rest of your day.